All right, here we go again. I now have what's called a crucible. A crucible has a lid. It also is capable of getting hotter. It's a thicker ceramic dish. So I'm hoping that's what we need. So I've got the crucible and the lid on my balance and I'm tearing it. And now I've got this nice big spiral of magnesium ribbon that I'm going to stuff down in there. And I want it to kind of stay in there a little better. All right, so now we've got 0.46 grams of magnesium. All right. Now, what I have here, this setup, is I've got this ring stand. I've got a Bunsen burner, which we're going to use quite often. And I have this thing, which is called a clay triangle, because it's made of clay and it's a triangle. This will allow us to hold the crucible over the Bunsen burner without having to physically hold the crucible over the Bunsen burner. I'm going to lower it just a little bit so that it gets nice and hot. What's going to happen is this ceramic is able to get a lot hotter than other materials. Oh, come on, Bunsen burner, don't you start with me. That's an awfully intense flame. That's all right. So what I'm going to do is I'm going to heat up this ceramic dish really good. And that is going to cause once the inside gets nice and hot, so the outside's going to start glowing red, the inside's going to get nice and hot, and this magnesium ribbon is going to start to ignite. Should start to ignite. It'll take several minutes, but that's okay. So this is exactly what you're going to be, well, the lab that you're going to be analyzing next week is about. So we're going to talk about why this gains weight once we get it to gain weight. And we will look at the ratio of the magnesium to what's causing it to gain weight. And then we'll be doing this experiment where we try out a few different, there we go. It's getting started. So we're going to try out this experiment with some different masses of magnesium, and we're going to start looking for the ratio. But one of the things that we're going to talk about with this lab is discussing experimental error. So what I see most often when students say there was an error in their lab, or I ask them what errors there were in their lab, they say things like, I could have read the balance wrong. This balance is digital. It goes to 2 decimal places. I guarantee that you're reading the balance very, very accurately. And if you aren't reading the balance accurately, like if you can't read a digital balance accurately, then maybe this isn't the class for you. So I am confident that you didn't read the balance wrong. The other thing I hear a lot is I could have done the calculations wrong. Well, if you did the calculations wrong, redo it. Don't hand it in until you're pretty confident, at least, that you did the calculations right. Those are not experimental errors. Those are human errors. And those are much easier to minimize. Let's see, it's sparking in there, but it's just not igniting. So in this case, one example of an experimental error, and it happens in literally every chemical reaction that takes place, is that you will never, ever react every last molecule of something. So this magnesium ribbon is made up exclusively of magnesium atoms, and it is not possible for me to ignite every last magnesium atom in here. Right? So there's going to be some magnesium that doesn't get reacted in the end, and that's going to affect our mass. The other thing that affected our mass when I was doing it on the open dish earlier is the fact that we lost all of that white ash. It was stuck to the tongs, it was fluffing out onto the table. So everything that didn't stay in that dish ended up lost on the counter, and that is lost mass. Right, so those are the kind of things when I ask you about experimental error, that's what I'm looking for. All right, this whole thing is glowing red hot. This thing has got to ignite. We're at about 5 minutes. Should be any minute now. I did this experiment, well, I do this experiment pretty much every year, not usually at the beginning of the year, but my class does it. And one year we lost every crucible I own because they were getting heated. Kids were washing them out and then heating them while they were wet. Ceramic is porous, which means water droplets can get in between the ceramic molecules and the whole thing explodes when the water expands as it heats. This is starting to go. Bottom is starting to heat up. I'm hoping it's going to extend up the metal a bit more. We may need to push the metal down a little. I'm going to clean these tongs off. And then I'm going to dry these tongs very well before I go poking them into the ceramic. And let's see what I can do here. As soon as I get it on the bottom there, I see it sparking again. A small piece along the bottom has already ignited and burned out. We just need to get the rest of it going. Oh, here we go. It doesn't even have time to glow white. It's just instantly reacting. I presume you can see the smoke coming out of this. Right, now that we've got it really going, I'm going to put my lid on just a little. I don't want this to be a completely closed system, but I also don't want any of that ash flying out of here. All right. Some nice little fires going on in there. When I do the lab for you, it's going to be this exact same thing. So maybe next time when we're doing the lab and I'm giving you the data, I will video. I'll use my phone and video what you see in the crucible because it's pretty cool. It's kind of glowing orange and then turning white, just like the white powder we got off of it before. Take the lid off for a minute, get it glowing again. And there's always going to be, as I just said, there's always going to be some metal that doesn't react, but I want to try to get as much of it reacted as I possibly can. poked on. I've got one piece that's kind of sticking out the top. I'm going to push it down in there. I lost a tiny bit of mass, but I don't think it's going to be significant. Most of this is now just all kind of blackish gray. I don't really have anything flying out of here. It's a little bit of glowing down at the bottom, but that might actually just be the crucible at this point. Glowing red. All right, I am going to turn off my Bunsen burner. I have this thing here, which is called wire gauze. This is if you wanted to have a beaker on your ring stand, you would use that. So you could set the beaker on top of it. I am going to use it at the moment as a hot plate because if I set this down on the counter, I will crack the counter. So we need to let it cool for a minute. If you put a hot thing on the balance, you end up with convection currents, which can cause your reading to be lower than you expect, or than it really is. I'm gonna see, can we see what it looks like inside without spilling it? You can see it's all just kind of nothing but that white ash. No. Luckily, the white ash is really stuck in there. You are definitely still too hot to touch. All right. When you want to see if a piece of glassware is too hot to touch yet, the best way to do that is to hold the back of your hand near the glassware. If there's enough heat radiating off of it that you wouldn't touch the back of your hand to it, then don't grab it with the front of your hand. All right, I think at this point I'm going to weigh it because it's the end of the school day and I'm ready to be done with this. So I'm going to bring this over onto the balance and I'm going to bring the lid over onto the balance. Maybe. So you will recall that when I weighed it the first time, it was around 0.4. And now we are at, can you see that? 0.96. All right, so we definitely gained a substantial amount of weight. So that's the basis for everything we're going to learn this unit. We are going to be working on explaining why this gained weight, what we ended up with, why this does or doesn't violate the law of conservation of mass, and then we're going to actually quantify, meaning with numbers, how much of the new element we are combining with to prove another aspect of atomic theory, which is that all atoms combine into small whole number ratios to form compounds. So I hope this was worth the wait, and I will check